Hello guys, welcome back to my channel. Now in today's lecture, we are going to discuss about model evaluation and the key techniques for model evaluation. Now first, what is model evaluation? It is a crucial for building effective machine learning models. It helps us assess how well a well-performed model on unseen data, ensuring its readability, usefulness in real-world application. This session explores key techniques for model evaluation in Python, which includes accuracy metrics, understanding common metrics like accuracy, precision, recall, and F1 to gauge model performance, confusion metrics, visualizing classification errors to identify area for improvement, cross validation, ensuring robust performance by testing the model on multiple subsets of data. ROC curve, and AUC, evaluating model discriminations by analyzing its ability to distinguish between different classes. Cost sensitive learning, handling scenarios where misclassification codes vary by adapting model training and evaluating methods. On further, we will discuss about each in detail. Now to the next slide. Accuracy metrics. It helps in evaluating model performances. First, accuracy. The most basic metrics. Accuracy represents the proportion of costly classified instances. It is calculated as the ratio of costly classified instances to the total number of instances. While accuracy is a good starting point, it can be misleading in case with imbalanced data sets. Precision measures the proportion of correctly predicted positive instances out of all instances predicted as positive. It is calculated as the ratio of true positive to sum of true positives and false positives. High precision indicates a low rate of false positive, which can be valuable in situation where misclassifying a negative instance as positive is costly. Recall measures the proportion of correctly predicted positive instance out of all actual positive instances. It is calculated as the ratio of true positive to the sum of true positive and false negative. High recall indicates a low rate of low negatives, false negatives, which can be essential in scenarios where missing a positive instance is crucial, such as in medical diagnosis. F1 score. The F1 score is the harmonic mean of precision and recall. It provides a balance between precision and recall, offering a more comprehensive measure of a model's performance than considering either metrics alone. A high F1 score signifies a model that achieves both high precision and high recall, making it particularly used in situations where both false and false negatives are important. As you can see here the diagram, here is fiat and recall, and it is the graph of precision. Now, confusion metrics. How we can understand classification errors. There are four types: true positive, false negative, true negatives. Now, here is the description. We will go one by one. The confusion matrix provides a visual representation of classification models' performance by summarizing the number of correct and incorrect predictions for each class. It's a powerful tool for understanding the types of error a model makes, which can guide model perform improvement efforts. True positives. What are true positives? The model correctly identifies instance belonging to the positive class. In spam detection, a true positive is correctly identifying an email as spam. More true positives means the model is effective at identifying the target class. Now, what is false net positive? The model incorrectly predicts that the instance belong to the positive class when it actually belongs to the negative class. In spam detection, a false positive would be classifying a legitimate email as spam. False positives can be problematic as they may lead to missed opportunities or inconvenience for user. False negatives. The model incorrectly predicts that an instance belongs to the negative class when it actually belongs to the positive class. In spam detection, a false negative would be classifying a spam email as legitimate. False negatives are particularly concerning in applications where failing to detect a positive instance has serious consequences, such as in medical diagnosis. True negatives. The model correctly predicts that an instance belongs to the negative class. In spam detection, a true negative would be correctly identifying an email as not spam. A high number of true negatives indicates the model effectively identifies instances that are not part of the target class. Now, moving to the next slide, precision recall and F1 score. What are they and what are they used for? They are basically used for balancing the outcomes. Now, precision tree focuses on minimizing false positives, crucial when false positives are costly. Recall emphasizes minimizing false positives, false negatives, important when missing positive instances in unacceptable. F1 score provides a balanced measure of both precision and recall. Now, handling unequal error cost, cost sensitive learning. First, what is cost definition? Assign different costs to different types of errors. Weight adjustment, adjust model weight to prioritize minimizing cost errors. Performance evaluation, evaluate model performance based on not just traditional metrics. Now, what are ROC curves and AUC curves? Accessing model discrimination. Now first ROC curve plots the true positive rate against the false positive rate. Now AUC curve, area under the ROC curve, quantifying the model's ability to discriminate between classes. High AUC curve indicates better model discrimination and prediction accuracy. Now here as you can see, here is the ROC curve and here are the positives, flea pauses, sag cases, false positives, and many more. Cross validation ensures the robust performance by random splitting, training, testing, and repeat. In random splitting, the randomly split data into k folds. Training the model on k1 fold. Testing evaluates the model on the remaining fold. Repeat the process k times using each fold as the test set. Now, putting it all together, model evaluation is an ongoing process. You can use these techniques to improve your model performance and ensures it meets your need. Remember, the best approach depends on the specific problems and goals. Now, this will be stay tuned for next lecture, and if you like the video, please subscribe to my channel.